All right, guys, let's go ahead and finish up page 20. So tomorrow when we start proofwriting, that we have all of the tools that we need to be successful at writing proofs. So all of you have your books with you. This is what page 21 looks like. It's basically proofs, but now we're proving triangles congruent. So we have to make sure that we're practicing all these tips and tricks to make page 21 and 22 a whole lot easier. So we are going to be doing proofs again tomorrow, so stick with me. We can do this. We're finishing up page 20. Let's do this. Can you tell that I have to like motivate myself to do this because it's really hard talking to no one. I miss you guys. That's crazy to say. No, it's not. You guys are awesome. But I miss you all. I miss our interaction. So I hope we can get through page 20 together, and hopefully we'll be back together soon. All right, let's learn some tricks. So these problems definitely look harder than these problems up here. These triangles are spaced out. They're farther away from each other. You can pretty much just label and go. But we need some tricks to help us on the harder problems. So let's practice trick number 1. If you're trying to label sides and angles, but you don't seem to have enough information, look for vertical angles. So hopefully we all are looking at this picture going, oh, vertical angles at D, at D. So vertical angles, remember, angle to angle, they share this angle. So angle BDC is congruent to angle FDE. Always think vertical angles. When we get into proofwriting, this will be called vertical angles. And also this type of problem I'm going to be referring to as a bow tie. So this kind of problem is look for vertical angles, look for the bow tie. So they look like little tiny bow ties, like little bow tie pasta, but these angles, they're the same angles and they are vertical to each other. So if you have triangles that are angle to angle, they will share an angle. Now, for the next one, we're going to talk about reflexive property of congruence. Okay, so reflexive property of congruence, what you want to do is focus on the two triangles that you can see. You've got a triangle located here, and we want to show that it's congruent to the triangle over here. We've got our two triangles. Now, to show that those two triangles are congruent, they actually share a segment. Segment BD. Let's find a good highlighter color. This is nice and, oh, blue's probably not the best choice. Let's go orange here. So BD. They actually share that segment. These triangles are adjacent and they share a side. So segment BD is actually congruent to itself by the reflexive property of congruency. So remember, POE was property of equality. POC is property of congruency. So when the triangles are side by side, they will share a side. Now, we write it twice because the first one represents the triangle on the left. The second BD represents the triangle on the right. That's why we're writing both of them. Even though they're the same letters, it depends on the perspective of the triangle. So BD is congruent to BD, meaning in the yellow triangle, it's also congruent to the one in the green triangle. So if the triangles are side by side, they will share a side. Always. Angle to angle, vertical angles. Side by side, share a side. Okay, last one is alternate interior angles. So remember back in chapter, 2, I guess? The one we just finished up when we were talking about parallel lines and transversals. Alternate interior angles exist. So what I'm going to do is trace our parallel lines and trace the transversal. Okay, parallel lines and transversal, which means this angle here and this angle here are going to be equal. So if that should be a single. If I redraw it like this, I have an angle here and an angle here. Now, the same thing exists on pictures that look like this. Now, we won't have double alternate interior angles unless these sides are equal, like in this example. But we'll come to that bridge when we get there. Okay? So let's try this one. You also have your parallel lines located here and here. So I'll use a different color for that to make it a little easier to see. Parallel line. Here is the first transversal. So you have congruent angles here and here, but you also have a second transversal here, making another pair of alternate interior angles. Now, obviously, there'll be more information to these problems because I can't use angle, angle, angle as a congruent theorem, but just look for alternate interior angles. So when you see parallel lines, I'll add when you see up here actually. I guess I'll form a complete sentence. When you see parallel lines, look for alternate interior angles. So just be mindful they exist. Now, we couldn't assume that over here because I didn't have parallel lines, anything like that. So look for the parallel. When you see parallel, look for alternate interior. All right, let's try some complicated ones. So number one, we want to focus on two separate triangles here. So I've got a triangle located here and a triangle located here. I'm going to label what I see. Bars get A's, curves get, no, that's wrong. Bars get S's, so sides, curves get A's. Now I can't just say, oh, that's side angle side, side angle side. That's not a thing. When you are comparing the triangles, you only get to compare one. So you actually have to cover up the other half of it. So right now I just have side angle or angle side. I need more information. So let's look back up at our pictures. These are not bow tie problems. There's no parallel lines, but they do share a side. So I can go ahead and mark, oops, drop my pen cap, these two sides congruent. So I can label these as S's. Now, when I determine how they're congruent, I'm going to cover up one of the triangles and just read it. Side, angle, side. Side, side, angle is not a thing. So just pay attention. List your options. So side, 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 angle, angle, side, or angle, side, angle. Okay. And just focusing on one triangle at a time, I have two sides and one angle. So this is out and this is out. To go back and forth between this one and this one, you have to look for the location of the angle. Oh, sorry, I crossed out the wrong one. No, I didn't. I have two sides and one angle, so that defaults. Just kidding. That defaults it to side, angle, side. So they have to be congruent by side, angle, side. Two sides, one angle. This is the only one that's like that. All right. So on this one, it just says to prove the two triangles are congruent. We don't have to worry about a statement. Now let's try this next one. Now notice again, we don't have some parallel lines marked, so we can't assume alternate interior angles, but we can see that we have vertical angles, just like we did here and here. So again, on this one, we had reflexive. On this one, we have vertical. It's a bow tie problem. So this is a bow tie. So we want to envision vertical angles. So I'm going to put double curves here. Now I'm going to go ahead and label. Bars get S's, curves get A's. All right. So now I'm going to list all my options. Side, 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 angle, side, angle, side, angle, 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 side. Remember to analyze, cover one of them up. So I have two angles and one side. The only one with two angles and one side is angle, side, angle, or angle, angle, side. Now you just have to determine where the side is located. The side is not between the two angles. It is off to the side. So it has to be angle, angle, side. It's all about narrowing down your choices. These problems may look more difficult, but they are the same level of difficulty. All right, now this one, number 3, is a little bit harder. Let's focus on the parallel lines. So this one is going to utilize trick number 3. I see parallel lines. I'm going to focus on alternate interior angles. So I'm going to trace these two out first. Parallel, parallel, and here is my transversal. Which means, based on that information, this angle and this angle can be equal. These cannot, because we're focusing on these lines here. Okay? So that's your first set. And we get those through using the yellow transversal. Now, I am going to turn the paper 90 degrees clockwise. Kind of 90. Just so these are the same. Now we have another set of parallel lines. Here and here. And they actually utilize the same transversal. Which means we have another pair of alternate interior angles. Here and here. And we get those by using the green parallel lines. Alternate interior angles. All right. We'll also have to utilize one of these two rules. So let's focus on our picture. These two triangles here and here, they are not left bow tie. They're not angle to angle. They're side by side. So side by side, you must use reflexive. So that lets me know that these two, my pen is rolling away, that these two triangles share this side. So to be able to do number 3, you actually have to use all the tricks in the book. So let's label. Angle, side, angle. Angle, side, angle. Hopefully now you're kind of seeing how to classify. If not, I'll write them down again. So side, 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 angle, 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 side. Again, when we're analyzing, we're going to cover up one of the triangles and then focus on just one, the one that's left. 2 angles, one side. Again, that brings us to these two options. Most of the time they narrow down to these two. Where is the location of the side? In this one, the location of the side is between 2 angles. So it has to be angle, side, angle. All right. For our last one, we should notice we have a 90-degree angle, which means when we're listing our options, side, 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 angle, side, angle, or angle, angle, side, and then we'll do angle, side, angle here. We have to actually add hypotenuse leg because we see the 90 degree. When I see a right angle, I can use hypotenuse leg because they're right triangles. That only becomes an option when it's 90 degrees. If this side is 90, we know that this side is 90 because linear pairs add up to 180. Let's go ahead and look at what we have. Across the 90 is the hypotenuse. And then they share this side using reflexive, which ends up being the leg. So this is hypotenuse leg. Now, just because it's a right triangle doesn't mean you always have to use hypotenuse leg, but it is a good place to start. Usually when we have right triangles, that is one of the options that we use to prove that they are congruent. Okay? So things to recap on, make sure that you're looking at your tips and tricks. They will guide you and help you look for parallel lines. You're going to be using alternate interior angles. Side by side, look for reflexive. Angle to angle or bow tie, look for vertical angles. All right, in our next video, which will be up tomorrow on Friday, we'll be talking about how to put all of this together in proofwriting. All of your practice problems for this are in your packet, but I will also be putting the IXL, which is homework still, on here as well.